Don't write anything, obviously, until I tell you to. But we need to get tan and cotan on there. So you really only have one statement for sine, cosine, secant, cosecant, and cotangent. Sorry. You have only, I got carried away with the 5 on this hand. You have only one statement that takes care of sine, cosine, secant, and cosecant. You find the stretch and sine and cosine, that's really defined as the amplitude. Why don't I call it amplitude on secant and cosecant? They don't have true amplitude. They do what? They go off to infinity. Amplitude is a wave coming at you with a certain height. Okay? So anyway, it just sort of captures all of that. The vertical translation, the phase shift, and the period. I've tried to make a big impression with my hands, okay? Cotangent belongs over here with the CSC, sine, cosine, secant, cosecant, cotangent. The reason I keep putting it over here, the period is shorter. Okay, so talking about cheating, okay? You kind of got your hands on your test and you can look at them and go sine, cosine, secant, cosecant, cotangent, okay? You're going, oh yeah, tan and cotangent. They're shorter. Their period is pi over. And I explain why. Granted, I teach really fast. But hopefully you at least caught that they repeat themselves positive, negative. Then it goes positive, negative, every 180 degrees. The reason cotan's over here is because once I teach you tangent, people want to keep splitting up cotangent. Tangent's the only one you split up and go out to, back to. Cotangent looks a lot like tangent. It's not a negative tangent. They have the same shape, but it's not in the same place. And I'll do some for you today, and you'll do some for me, Colin. But cotangent starts just like sine would. You get your starting place, your phase shift, vertical translation, and then count out 1, 2, 3, 4, and draw whatever the appropriate graph is. We'll talk about all of that before I get super started in class. But I want to just lay the foundation for what's going on with tan and cotan before you move forward, because I forgot to put in your memo page. Sam?
Can you explain the hand thing that you were
The other day I wrote S, C, S, C, C. They all have S's and C's. Tangent starts with a T. It's different. The reason all 5 of these are together is you treat them all the same way. You find your starting place and count out straight out 1, 2, 3, 4. And I make a big impression of that because a lot of you would agree on your homework that I need to check that once you learn tangent, you try to force cotangent into that same box. Tangent, you could count out 1, 2, 3, 4, but it's kind of silly to do so because you run into an asymptote halfway through it. And again, I teach really fast, but I showed y'all that the other day. So the significance of this is that all 5 of these CSCs have a phase shift starting place, and you count straight out 1, 2, 3, 4. Tangent's the only one all by itself on this hand that goes out to, back to. Okay, and some of y'all would agree, you get to a cotangent graph and you try to treat it like a tangent graph. There are definite similarities. They have a shorter period and they're curvy, like an S-curve. Okay? All right, so anyway, I'll step aside a minute for you to write this, but not yet. You're not writing yet. All right, this is the vertical translation. This is the stretch. It's not going to have true amplitude, but that'll show that. How does that affect the graph? I really haven't shown you that yet, so you're not writing on your memo page. You're just watching me. If I'm graphing y equals 4 tan x, and I'm not going to take time to pull up the calculator. I probably should do it on Desmos, and you would see it. But what happens is I go out 1, 2, asymptote, back to asymptote, dot in the middle. Okay, immediately to the right of it, a fourth of the way to the asymptote, immediately to the right of my target, everything goes up. So this one will go up 1 unit. Let's talk about why. If I actually took time to label this, the period of tangent is pi. I divide it into 4 equal parts, and tangent's over here. It's the one where I go pi over 4, 2 pi over 4, and then I go back pi over 4, back 2 pi over 4. The tricks are awesome for graphing, but sometimes it helps to understand why you're doing what you're doing. Right here at pi over 4, what is the tangent of pi over 4? It is 1, isn't it? That's why that dot is there. The tangent of negative pi over 4 is negative 1, and it gives you the shape of your graph. And I would never on the test let you just graph one of them, so keep counting by pi over 4s. Now what if I graph this one? When I get to pi over 4, order of operation, the tangent of pi over 4 is 1, but then I multiply it by 4. And so do you see how it stretches this graph up this way, why I call it a stretch? It gives you some really important numbers to lock into, and it gets very stretchy, okay? But it always happens at these two places because that's where 45 degrees would be happening, okay? Where tangents are 1 and negative 1 unless you multiply it by something, all right? Rebecca?
So on a test you would need to mark off, like you would, like the little 4 thing, like you would mark off the amplitude of,
The stretch at 4.
I mean like you would need to like mark that off and like label it on a test.
Don't dare give me a graph without every single thing marked off and labeled. Notice I didn't label that, Rebecca, so we assume that it's 1. If you want it to be 10, 20, 30, 40 going up and down the y-axis, you need to tell me. With just a 10 and a 20. Yeah, don't ever give me anything that's not labeled. I won't count it. Think of all of your parents right now, literally all of them, are probably during this day going to look at a graph at their work. Whether it's the stock market, whether it's somebody's heart rate if they're a doctor, whether it's housing prices in Jersey City, they're going to be looking at a graph somewhere in their job. And if it's not labeled, it doesn't mean anything, right? If it's not labeled, when I get like medical reports from Sun Kettering and they show me this like CA 125 thing that they watch, if it's not labeled, I don't know if I'm in danger of something or not. I pretty much need the numbers. You see what I mean? Okay, so it's real important that we do that at this stage. I tell you what, let me talk for a minute. I'm probably going to answer your questions so that we're most efficient. So don't raise your hand right now.
No, I'm just wondering if you're recording or not.
I am, thank you for reminding me though. It's always a good thing, yes. And please, if you're prone to forget your question, just write yourself a little note what you want to ask. So anyway, let me go back to this so we don't lose our train of thought too much. So memo page. Where I was at stretch. Okay, and this, you'll find this right here, hopefully you know from algebra, putting a number right here in front of x will do a horizontal shrink or stretch. And it's based on the period of a tangent graph which we have found to be pi. And so you say pi over c, not 2 pi over c, okay? And this combined gives you the phase shift. You set that equal to 0. All right, let me pause and get that on your memo page. On memo quizzes, I wouldn't try to trick you and say, what's the amplitude of 5, 10, x? I'd probably say, what's the stretch? Okay, if I say what's the amplitude, say there is none. Petra?
With regard to the variables, is it always going to be set up like that, or is it possible to be set up with like a sign where the A in the front is at the back and is right?
Sure, absolutely.
Okay.
Yeah, it's just like you could have x plus 3 or 3 plus x. Is that what you're asking?
Yeah.
Yeah, and you've seen all of that.
Yeah. No, I'm just saying
Yeah.
because the variables are in different locations than when we did sign.
Well, some people don't even use A's, B's, C's, and D's. It's
Yeah.
that you know where they are and what they do. So that's a great question. Some years I probably don't even label in the same way, Pietra.
Okay. Thank you.
Oh, you mean with sign? Did I have A in the back?
Yeah.
Well, it was like D.
It was like D, so A was B.
Did y'all want to do it that way? Will that help
I'm
you?
just doing it like that because it's.
Yeah.
It's like that.
Y'all, is everybody writing in pencil?
Yeah.
Okay. I don't, but good for you. Okay, thanks, Pietra. Let's be consistent on our memo page. I'm sorry. Like I said, some years I don't even use that. Apparently, I just came out of my head what I used to do. All right, so help me get it placed right. A, tangent,
Then like B.
B, no, I wouldn't have done that, did I?
Yeah.
Let's see. Yeah.
Wow. I'm not going to do that again. I'm used to CX plus D. I say it all the time, don't I? But anyway. All right, so this is the stretch.
Wait, is the last letter D?
Uh-huh. This is vertical translation. Again, Lindsay, I know you want to write the number down, the letter down that I wrote, but the letter doesn't matter. It's where the letter is and that it's added causes go up and down. This gives you your phase shift. And your period is 2 pi, is pi over b. Did I have pi over b on your memo page?
Yeah.
Gosh, I don't know what I was thinking that day. It doesn't matter, I just never do it that way. Okay, I'm going to move on so you sort of see where it is in the slides. It's on this Russell slide if you need to look back at it later. Okay, so now let's just talk about some things. If I have sine of bx plus c or tangent of bx plus c, blah, 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 blah. Why are there questions?
I was wondering something about the memo quiz we have today. It had the thing from this, like that we just added to our memo page, but we didn't have it from before.
Oh, well, you've already had homework on it, but that's a good point. I'll just throw that one out. That's a great point, because if you felt, yeah, I see what you mean. Yeah. If you got it right, I'll count it for those of you that got it right. But I felt like you're right. I just taught it last class. So I'll throw it out if you missed it. Thanks for letting me know that. If you didn't hear what Rebecca said, she pointed out correctly, and please always do that. I really just taught that on Thursday, and you just now put it in your memo page. So if you missed that, that's okay. I'll just throw that one out, and if you made a 90 because of that, I'll count it as 100. Okay? I'll just give you that point. Sorry for those of you who got it right. Maybe I'll give you some bonus points somewhere or something. I'll try to look at that when I'm grading it. We could discuss it later. I'll try to be as fair as I can always. Pietro? Why am I answering questions? Don't write your question down. I'm going to talk, okay? And most people will just have scratched their question out by the time I get finished talking. One thing that you will have to do on the test that we're going to practice some today is what some of you, most of you chose to do is try to write an equation from a graph, okay, or from data. Your data actually made a graph, and you were trying to match your graph to the data. Guess and check, I did not accept. Many of you met with me, and I'm like, where did these numbers come from? And if you just kind of tried to slide it around there, that's not what a good mathematician is about. You wouldn't keep your job very long if you're back in your office just moving it, hoping that it fits there, because there's going to be somebody that knows the math that can go, bam, this is where it should be, and I'm on to the next problem. So the phase shift, I think, is the hardest part to see. If I had a graph that I wanted to shift over, say I have this graph, say this yellow graph is going like this, and I know that I've labeled this like 0, pi over 2, okay? I can see that I want to shift my sine graph over pi over 2 to the right, okay? Do you see I want the white graph to be in sync with the yellow graph, okay? I want to be able to shift it over. We don't have time for this, the pace at which honors pre-cal goes, but when I saw my honors pre-cal classes every day at another school, we had time to actually look at some people that in their job were actually turning the dials, like you see people back on sound crews if you're at a big concert, they're doing this kind of stuff, okay? They're making sure that the waves are right. They're looking at waves. I know that sometimes even when I'm sitting at church and I just glance over at the person with all the monitor stuff, I see, or even in your, maybe if you have a stereo system at home or on your car, you even see a little wave now that you maybe didn't notice before. So there's reasons for it to be in sync. So anyway, please know where things come from. Your phase shift comes from bx plus c or cx plus d or whatever letters that you're using. I could use, y'all all realize I could use zx plus w, right? Okay, it's just where the letters are. It's not what the letters are. Girls, listen, it's one of the easiest things to clear up, which a lot of people find difficult. I did until I realized, wait, the algebra is almost always going to save me. If I understand the algebra, I can do it. I've taught you to get your phase shift by doing this. Most of us do it in our head, like this. What's the phase shift? Pi over 2. But didn't you actually change this sign to go to the other side and then divide by 2? So I can easily see, this right here is my phase shift. It will always be the opposite of this number over that number. Do y'all see what I mean? Always. Where people mess it up is they try to figure out, they think they want to move it over 1 or pi over 2 or something, and they want to put that number right there. Meanwhile, it's interacting with this number out here, and you're not thinking about that. So the safest thing to do is to realize this is my phase shift and force it to move over pi over 2. Chances are high that you've already figured out what b is because you know the period of your graph. So if I already know what b is, do you see I only have one variable to solve for? It takes care of it. I'll do a concrete problem, but it's just, really being a mathematician is just over and done with, and you're on to the next problem. You can just knock things out really fast. I think most people understand the vertical translation, the amplitude, and all of that, but we'll talk about it. All right, now I just want to talk about the basic graphs. Once again, look at this. That's supposed to call to mind pi, okay? That's supposed to call to mind pi. This is tangent. It's the only one where you start with your phase shift and go out 2, back 2. I try to make a big deal about that because you cannot imagine how many cotangent graphs I've graded where I've told people, don't go out 2, back 2. That's not what cotangent does. Let me show you. I think it's probably worthwhile to do this. I'll do it on Desmos just because it'll probably come up faster than the other thing. So, to me, I wish somebody had taught me this much with pictures, like visualization, because I think if you can see it, it helps you keep it or take ownership of it. If I make my window here go from, if I know the period of tangent is 0 to pi, if I know the period of tangent is pi, let's see, if I graph sine 2x, all right, I'm not going to put the x in yet. Probably need it in parentheses, actually. But as soon as I put this x in here, what will the period of sine 2x be? 2 pi over 2? It'd be pi. Okay, and do you see one sine wave with an amplitude of 1? And then you would, on the test, you'd have to draw a couple more. Just keep counting out by whatever you're counting. All right, so that's good. Cosine works well, too, if I put in cosine. Notice that I'm making these have a period of pi. Doesn't that look like your normal cosine graph? Okay, secant and cosecant would follow suit. Now I'm going to take the x out, and I'm going to change this letter, the s, to a t. Okay? So now I'm going to make it a cotangent graph. And notice I took the 2 out. Okay? Because cotangent's finished by the time it gets to what? Short pi. All right? So you'll see one complete cotangent wave when I change this letter. That's a great way to teach it. Just have you start at 0, which also turns into your phase shift later on, right? Like I don't care if this is 0, 0. I can start from wherever you tell me to. And I'm going to count out 1, 2, 3. Wait, I'm sorry, I missed it. Well, here, I'll change mine. This will be even better. Let me change my count to pi over 4. Step. Pi over 4. Okay, so now do you see how I went out? I started wherever wherever your phase shift would be for sine, cosine, secant, cosecant, or cotangent. And I go 1, 2, 3, 4, done. Okay? Do y'all see how, I'm gonna throw sine in here. And so that you can compare them, I'm gonna make it sine of 2x, just so you'll see the whole thing. Maybe. Sorry. And I'm gonna put in cosine of 2x. Okay. There's a lot going on in here, but what I want y'all to notice is something that I'm saying. I don't care if this is 0, 0. Y'all understand that's my target? That's my phase shift vertical translation. I don't really care where it is. I can draw a graph from anywhere you tell me to, so can you. All right? Immediately to the right of your phase shift, do you see how if it's positive, everything goes up first? Do you see immediately to the right of your phase shift, you put your dot, and sine's going to go up unless it's negative. Put your dot right, put your target here. If it's cosine, don't you go up to the amplitude? And cotangent starts high, okay? Immediately to the right of every phase shift, your graph's going to start in the positives unless it's negative and then flip it over. You can always bail yourself out with your brilliant mind. You know, I can teach honors a bit differently because you probably grasp the understanding. If I forget, I can just fill in a point. Like if I fill in pi over 4, I know that the tan of pi over 4 is 1, therefore its reciprocal is also 1. Do you see you can actually, it's not that you can't go back and fill in those points we found by trickiness, right? Your question. All right, now, I'm going to throw in tangent. I'm going to get rid of all of these, so you'll probably be relieved. There's a lot going on in here. All right, now here's tangent. Do y'all see why I don't teach you? Because nobody does, not just me. But if it was just me, I would not teach you to graph tangent by going 1, 2, 3, 4, because you slap into an asymptote in the middle of your problem. Because where cotangent was 0, what's the opposite of 0? Undefined, okay? Having everything, which you can't define either one of those really, but it's going off to infinity. Do y'all see what they're saying? So why in the world would someone teach you that? You see it's going to make more sense when I just want to go out to put an asymptote. I still need 1, 2, 3, 4, but where's my 3, 4? It's back that way, right, Isabel? So I teach you tangent to do this. I'm going to go negative pi over 2 to pi over 2 to get one wavelength. Do you see how pretty that is? It just makes sense. I really don't care if you go to your target and go 1, 2, 3, 4 and put an asymptote right in the middle of your graph. Most people don't though. Most people go, oh, this is tangent. Kind of weird, kind of short, okay? And it's also just does things differently. All the other trig graphs go out 1, 2, 3, 4, and you draw the pattern. Tangent's the only one, I can't stress it enough. Cotangent does not do this. Tangent goes 1, 2, asymptote, back to asymptote. Put a dot on your vertical translation phase shift on your target, and look what happens immediately to the right of my target. It's going up, isn't it? Okay, so I'm going to draw those on the slides in a very lackadaisical form, okay? So if I'm graphing sine, can y'all see that black okay, or should I change? I'll change it. Okay. I don't know why that won't go away. All right. If you're graphing sine of blah, 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 okay, like a big old, ugly sine wave, all right? So I would go to wherever my target is. If it's sine, I put my dot on the target. If it's positive, don't I go up first? Okay, now let's talk about cosine. Blah, 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 meaning that it's got a bunch of junk in it, okay? Find wherever my target is. It may move over and down. This is my target. With tangent, do I put my dot right here? No. Where do I put my dot? I'm sorry, with cosine, where do I put my dot? Up wherever the amplitude is, right? All right, and do you see immediately to the right of this phase shift cosines in the positives? Just like sines in the positives at first? All right, now wouldn't that be true also for secant and cosecant? Because how do you graph those? With the sine-cosine pattern. Are y'all okay with that? So if I'm graphing y equals cosecant x, blah, 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 I'll find my target. And if I'm graphing cosecant, what word am I thinking of? I'm going to graph sine first. And if this is positive, I'm going to go up first for whatever I think my sine wave is. Okay? So now when I get to tangent, and by the way, obviously every single year I expect some confusion the first time that you do it. Let's get rid of the confusion though. And you can get rid of the confusion. Okay? So say blah, 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 blah. You get your phase shift and your vertical translation. Okay? With tangent, that is going to be where your dot goes. Okay? On your phase shift vertical translation. And you don't count out 1, 2, 3, 4 with tangent, but tangent's all alone in that. You count out to asymptote, back to asymptote. Come back to your target, and then you're thinking, oh my gosh, I don't remember which way to twisty turn it. Immediately to the right of your target, what do? You go up. The way it can be confusing is right now my target's in the middle of the graph. So just get over it, okay? There's my phase shift. I've got my asymptotes. Now I need my 2 points. With tangent, if you get confused, there's 2 things you can do. One of these 2. One of them is just remember, go back to your phase shift and go immediately to the right and go up, hands down. Okay? Another thing is if you don't really know, just fill in this point. You've got a great calculator or a great brain. It'll be something that you really will know if you fill it in. Okay? We'll do that a little bit in just a minute. All right, now what about cotangent? Blah, 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 blah. Okay? You'll go to your target. Zana started to solve today. Which hand is cotangent? It's on the CSC hand, right? So you treat it just like you're about to draw a sine wave. Okay? Here's your phase shift. You count out 1, 2, 3, 4, asymptote, asymptote. Okay? I just counted out 1, 2, 3, 4, and I got ready to draw whatever I was going to draw. Now, you don't go, oh my gosh, which way do I twisty turn this, okay? Immediately to the right of it, what should you do? The right of your target, you always go up. Okay? All right, now I'm going to do one from your homework. Will someone pick one from your homework for me to do? All right, oh yeah, and you had asked for 5. Well, how many did I give you?
There's 10, but there was 5.
5 and 5? Okay. And I think I did some on the videos. If you haven't watched them, did I do a couple for you?
No. You did like, not from the worksheet.
Oh, I
You
did
like-
some examples.
Yeah,
I found the empty room and I just started making up stuff. Okay, girls, by the way, if your hand was raised just to go to the bathroom in the nurse or something, you can go. You don't have to raise your hand for that. If you have your hand raised for a question, you have to wait. All right, would you read me number 4, Elena?
Yeah. Y equals 2 minus 5 cotangent 2x minus 5.
Okay. All right, so it has a, I always start with amplitude or stretch. All right, so it has a stretch of 5. It has a period of pi over 2. I'm going to pause. Is everybody okay with that? Pi over, little bitty short thing, okay? Pi over 2. I'm going to count. Are y'all okay with pi over 8? Okay. Phase shift, anybody? Pi over 2. Vertical translation? 2. This is my new target. I'm going to go pi over 2. I'm going to give myself some room to make sure I count because it does, like back to Rebecca's question, of course in an honors class like this it needs to be drawn to scale. If you found yourself trying to squeeze in more points, you probably should just erase it or scratch it out and redraw your graph so that you can plan accordingly, just like you would if you were doing 10, 20, 30, 40. All right, I'm going to call this pi over 2, 2. There's my target. Okay. Cotangents with the CSC hand. So I'm going to count out 1, 2, 3, 4. What am I going to count by? Pi over 8. I'm going to go with all of these hands, this entire hand. I'm going to go to my phase shift and I'm going to count forward 1, 2, 3, 4. And then I'm going to think, what does my graph look like with every one of them? I'll make a sine, a cosine, a secant, a cosecant, or a cotangent. So I'm going to count out, I need to change these marks a bit. If I'm going to have you draw them to scale, I need to also. I'm thinking about how big pi over 8 would be in relationship to pi over 2's. So what do I need to change this to so I can count by pi over 8's? 4 pi over a. All right, so what's the next one? 5 pi over a, 6 pi over a, 7 pi over a. What's the next one? Pi. Okay? Now, you think to yourself, what graph do I have? Once you get all 5 of them laid out with a cotangent, once you count out 1, 2, 3, 4, you have an asymptote at the beginning and an asymptote at the end. You always have a dot right in the middle. Your question now is going to become, which way do you draw it? Where's your phase shift, girls? Locate it with your eyes before I do. Here's my phase shift. I don't care what graph you're doing. Immediately to the right of your phase shift, you will always go up unless it's what? So what is this one going to do? It's going to go down 5. 1, 2, 3, 4, 5. Right here. This one's going to go up 1, 2, 3, 4, 5. Right here. And now I'm going to draw some more. We said this was 4 pi over 8, so now I'm going to count backwards by pi over 8. This is 3 pi over 8, 2 pi over 8, 1 pi over 8, 0, negative pi over 8. So I have this running through here. It's a very stretched out cotangent graph that just goes on and on like this. That last one was horrible. I should just erase that. But anyway, you should draw better ones. That's fine. That's what I'm looking for on the test, except for that last thing I drew. All right, now I'm going to do another one. Let's do the last one on that page. Isabel, I think you asked for that. Was that you?
Yeah.
All right, what's...
To draw more than one.
I'll say draw 2 or 3 periods, but yeah, I want you to always draw more than one because we can't forget that they go on forever. Did you see how Lily snuck that question in there? All right, what does the last one say, Isabel?
Y equals 2 plus 5 cotangent, in parentheses 2x plus pi over 2.
I'm sorry, just quit cooperating with me. Okay, start over, sorry.
2 plus 5 cotangent 2x plus pi over 2.
Okay, the stretch is 5. The period is pi over, it's cotangent, pi over 2. The count is, again, pi over 8. The phase shift, anybody get the phase shift? Negative pi over 4. And the vertical translation? 2. I'm going to start here. All right, so I'm going to start back, negative pi over 4, and up 2. Here's my target right here. This is my target. Okay. Then I go and look at what graph I have. Girls, if it's a sine graph, I'm going to put a dot on that target. If it's a cosine graph, I'm going to put a dot start above the target. Okay? And I'll do the same for secant and cosecant. I'll graph sine or cosine and flip them over. Okay? If it's cotangent, which this one is, immediately to the right of the target, I'm going to go up. How far? 5. Because it's positive. Okay? So immediately to the right of my target, oh, I didn't label. I'm going to do that now. I'm going to make this negative 2 pi over 8. Count by pi over 8. This is negative pi over 8, 0, pi over 8, 2 pi over 8. So when you are on cotangent, you have an asymptote at the beginning and the end. Immediately to the right of this, you're going to go up 1, 2, 3, 4, 5. You're going to come back at the middle. You're going to go down 1, 2, 3, 4, 5. And then I'll model for you drawing another one. I ended at 2 pi over 8 right here. So this would be 3 pi over 8, 4 pi over 8, 5 pi over 8, 6 pi over 8. Label enough of them for me to know what you're counting by. Middle, up 5, down 5. You have a really Christmassy looking graph on your Halloween page. So let's do a tangent one, all for your homework. So I'm still not taking questions. Again, there's a reason for that, is we'll get bogged down, and I don't want to get bogged down. So I want to go to a tangent graph, and then I will take questions. Does anybody have a tangent graph they want to see? Or will somebody just call out one of the tangent graphs?
Y equals 5, 10, 3x plus pi plus 4.
Okay. So the stretch is 5. The period is pi over 3. The count is pi over 12. Phase shift, negative pi over 3. Vertical translation, 4. Are y'all okay with that? Okay. So I'm going to move back by negative pi over 3, thinking about I'm going to leave myself some room to count. So I'm going to call this negative pi over 3. Pi over 12s are pretty small in relationship. They're a fourth as big as a pi over 3. What do I need to change this? I'm sorry, I couldn't even read my own phase shift. This says negative pi over 3. I'm going to change that to negative 4 pi over 12. Are y'all all right with that? Girls, this is a tangent graph. This guy's different. I'm not going to count out 1, 2, 3, 4 like I am with these. That's why I keep holding up this hand. With all of these, you get your phase shift. Well, I probably should do it this way because that's facing you. You get here and you go 1, 2, 3, 4, draw your graph. Tangent's the different one. You don't do that. You go to your phase shift and go out 2, back 2. 1, 2, 3, out 2, back 2. Out 2 for 1, 2, and then back 2 for 3, 4. All right, so I'm going to add pi over 12. So this is negative 3 pi over 12. What am I at? Negative 2 pi over 12. Put an asymptote. And then I'm going to go back to, put an asymptote. Here's my target. I forgot to put my 5. Probably shouldn't be running into all of this. All right, so my target was at negative pi over 3, 5. I counted out 2, asymptote, back 2, asymptote. Immediately to the right of my phase shift, I'm always going to go up unless it's negative. This is a positive tan graph. So from this 4, oh, I'm sorry, the vertical translation was 4. Okay, sorry about that. Vertical translation's 4. So I'm going to start over, not completely. My target was negative pi over 3 up 4. Okay, immediately to the right of it, I'm going to go up 1, 5, 6, 7, 8, 9. To the left of it, I'm going to go down 5 and draw this one. And then I'm going to keep counting. Here I was at negative pi over 6. That was negative 2 pi over 12. Negative pi over 12. 0. Pi over 12. 2 pi over 12. The asymptote. Dot right in the middle at 4. To the right of that is 9 and back. All right, there were a couple of faces in the audience when I said, if you get confused, you can always fill in a number. They're like, no, I can't. It's a pi over 12, Miss Lazari. Watch this. If you're like, I don't know what to do. I got my dot on my phase shift. I don't know which way to turn it, okay? That's, let's do this one, pi over 12. What's 3 times pi over 12? 3 pi over 12. 3 pi over 12. Pi over 4. Then it says plus pi. So that's, what did I say? What's pi over 4 plus pi? Yeah. Pi over, you wouldn't want to do all this in your head, but you get 5 pi over 4. But you should know that the tangent of 5 pi over 4, you ought to be able to do that with your memo page quizzes. Tan of 5 pi over 4 is 1, because it's in the third quadrant, where tangent is positive. Okay? 1 times 5 plus 4 would give you 9. You see you can find that point? Okay? It's quicker than putting in your calculator trying to use table. All right, questions? All right, Elena?
So if it's like regular, like not co-tangent or cosine, then it starts at the phase shift.
Like it starts at a
All
certain point. Like, there's a
sine,
point.
cosine, secant, cosecant, and cotangent all start at your phase shift. But the only one where you actually put the dot there is sine, I guess cosecant technically, because you're going to graph sine to graph cosecant. And tangent's dot goes right on the phase shift.
Okay, so if it's
Isabel?
This is not like specific to Tanner.
Okay.
Graphs, but I always mess this up, and it's because I don't know why we do it. But like to find the count, why do we divide the period by?
Because we could find all these other little crazy points, but if you and I just set out to graph y equals tan x or sine x or cosine x, remember those xy charts you did? Those long xy charts, those aggravating things that you filled in like 20 points per graph on that first discovery page I gave you? Hopefully you realize after the second or third one that that was like a huge waste of time because you were just looking for where it hit 3 and negative 3. And that always happens a fourth of the way through it. Okay? Just like our seasons or how we just are prone to count 1, 2, 3, 4, 1, 2, 3, 4, the quadrants. All of that important stuff is going to happen. So what you and I want to know is what tangent of 0 is 0. And then if I count out 1, 2, 3, 4, at pi over 2, tangent's undefined. At pi over 4, tangent is this lovely 1. At negative pi over 4, tangent's negative 1. When you're doing sine and cosine, it's going to hit those max and mins, those highs and lows, always a fourth of the way through because of how your circle's going. Okay? Yeah. So many things we divide into 4 equal parts in real life. Just 1, 2, 3, 4, 1, 2, 3, 4. Okay?
I just write everything with the same denominator because I get
Oh, yeah. You do not have to reduce. It helps me to count sometimes. I know the pen up here is so fat that I've reduced some so I can squeeze them in there. And you don't have to write every one of them, Michaela. If you write 2 or 3, I know what you're counting by. Just establish it. Just like if I decided to count these by 5s, all I need is a 5, 10, then I got it. Okay? So those are good questions. Lindsay?
So for the tan graph, so do you go to the right or the left first, like to know if it's like negative or positive?
What'd I say? Every single time you go to your target, and then what do you do?
You go
For every single one of them.
to this way and then to the other way.
Okay, right, but then you go put your pencil on your phase shift for every graph, whatever graph you're drawing. I don't care if this is about 2D sine and I'm going to do that. I don't care if it's about 2 cosine, I'm going to do that. Go to your phase shift, you have your target, immediately to the right of it, all 6 graphs are what? Positive. It goes exactly what Michaela was asking. Michaela and I are about to enter, I'm sorry, it wasn't Michaela, who asked me about counting by 4s? Oh, is it Isabel? Okay. When you're going through your quadrants, we could divide this up into 1, 2, 3, 4. Okay? When you're going through your quadrants, the first quadrant on all of them is what? Positive. So go back to your brain, go back to your phase shift, immediately to the right. If it's positive graph, whatever dot you're about to draw will be up. If it's a negative graph, then just change your mind and draw it down. Okay? Tangents, that's why we keep putting it over here, okay? Because the phase shift's right in the middle of it. You gotta go back to that.
And there will be like questions on the test where you give us a graph and then we have to like say the.
Let's do that right now. Pietra, did you still have a question?
No.
Okay. You're writing them all down. All right, so pass these around real quickly. Okay, does everybody have one? Almost? All right. There'll probably be some extras. I'll just grab them later. Oh, they should all be stapled. Did you get a stapled one? Okay, good. All right. Everybody got one? All right, let's do number 1 together. Here, thanks. I'll just save them for... Oh, and Chloe's going to remind me if I don't do this after when I post the assignment, like exactly what to study for the test. I also will attach blank worksheets that you can practice and then check against with the ones we did in class. Okay. Also, it's not a bad idea to go back to previous assignments or videos that I've sent you. I put almost everything also under topics, class notes. If I make an extra little 5-minute video, I usually put it there if I remember. And you could like look at the video and see what question I'm about to graph and try it and just pause the video and see if you get it right. That's another way to practice it. All right, on number 1, raise your hand if you know the amplitude of this graph. How about you just yell it out? Okay, so 10. So the amplitude is 10. All right, can anybody figure out the period of this graph? How long does it take this graph to finish one complete cycle? It's kind of, yeah, 4 pi. All right, how do we know that the period is 4 pi? I think it was kind of hard to tell toward the end, but if I look at this graph, like if I look from bottom to bottom, you can see it's going from negative 2 pi. Your eyes just need to find a place where it's completed one full cycle, okay? Bottom to bottom, middle to middle, top to top. So the period is 4 pi. Phase shift, well, let's make a decision here. If it's a sine wave, what would you think the phase shift would be? I know. Thank you. Thank you. If it was a sine graph, what would the phase shift be? Negative pi. So I'm going to go to what Bella said. Negative pi if it was a sine graph. Unless you wanted to do a negative sine graph. Do y'all see how I'm going to have to grade whatever you wrote? I could get 5 or 6 different things here, couldn't I? Hang on just a minute. I know what it says. Thank you. Yeah, y'all, I've already been told what it says, and we're going to talk about that. I'm trying to make a point, okay? I could graph this as a sine graph. I'm sorry. I could think of it as a sine graph, a cosine graph, a negative sine graph, a negative cosine graph, okay? Why do you think this sheet says in bold? I wish that wasn't even there. I didn't make out the sheet. I wouldn't have said that. But what's going to be the most convenient way to write this thing so you don't have a phase shift? This is cosine. All right, so let's put 0 for our phase shift here. Vertical translation? 0. So now let's try to go backwards and write our equation to make this happen. All right? So now we're going to use our algebra. The vertical translation is 0, so I won't even write anything there. The amplitude is 10. I think we're all planning to do a positive cosine graph. And now don't just fish around. Be very clear. If the period is 4 pi, you've got to force that to happen. 2 pi over b or c or whatever letter you want to use in front of x, okay? It's got to be 4 pi, right? So I'm going to cross multiply. It is. And I'm going to get 4 pi b equals 2 pi. B, Chloe's already reduced it to 1/2. Now here's a cute little trick if you're trying to force the period. 2 pi over b gives you the period. Watch what happens if I cross multiply. 2 pi times 1 equals b times the period. So if I'm trying to find out what b is, I can say 2 pi over the period. I don't know if you just saw what just happened. You say 2 pi over b to find the period. If you're trying to write the equation, you can say 2 pi over a period to find b. Do y'all see what I mean? So I could do it a little quicker going 2 pi over the period will give me this b coordinate. And then to find the phase shift, I don't need to do anything, do I? Because this one doesn't have phase shift. Now what if I said write it as sine? That's why I kept going, yeah, I know what it says. What if I said write it as sine? Let's write this one as a positive sine wave. It's going to start right here and be a sine wave. You would be very justified in saying, why would I do that? Right now, just because I want to. So talk about it, because everything's not going to start in a convenient place. Like your temperature graph. Most of y'all saw it as a negative cosine, but you still need to shift it over a bit. All right, amplitude. Period of the sine wave is going to be the same thing. It's going to have the same period, so I'm going to use 1/2 x. But now I need to know how far it is shifted. How far back did it go? All right, so it went negative pi. And so my phase shift comes from this. 1/2 x plus some number is going to give me my phase shift. It's going to be negative c over 1/2. It's going to give me my phase shift of negative pi. Remember how you find your phase shift? It said 2x minus pi. Wouldn't your phase shift be pi over 2? Okay, so what I'm doing is saying negative c over b and forcing my phase shift to be what I want it to. So I'm going to say negative c equals negative pi over 2. So what is c? Pi over 2. So I'm going to say plus pi over 2. Now do it in your head. And if you, I'm keeping an eye on the clock. If I check my phase shift here, and I say 1/2 x plus pi over 2 equals 0, I would get negative pi over 2. I would divide it by 1/2 or multiply it by 2. I would get the right phase shift. All right, so let me say one more thing about that and then we'll go. Remember where your phase shift comes from. If I'm trying to force a phase shift, if I want it to shift to the right, pi over 2. And I've already figured out the period by saying 2 pi over the period, let's say that's pi. And so I want to put a 2 in front of x. And I want this to be my phase shift. So I'm trying to figure out what this number is. I'm always going to say negative c over the number that I already figured out for my period and set it equal to my phase shift, and you'll know what number you should put there. It'll always tell you, okay? There's only going to be one where you're writing the equation. There'll be probably some matching where you've got graphs and equations, but it's kind of up to you how you want to handle that. But there will be one where you have to write the equation. So I will probably not make a video because you're probably super sick of them. But I could if you want me to, or send you one of your own. But I'll post the answers, like the answers I would write to this worksheet. Granted, there can be some other answers. You could email me and say, would this work? And I'll let you know, okay? So I'll post blank worksheets, answers to this, and what to study for the test. I'll also open up some Delta Math. All right? Bye, girls. Please see me if I didn't answer your question.